This is George.
Okay, so this slide is quality gates catching issues before they ever reach production. Let me talk about quality gates, which are the key part of how we prevent the issues from reaching production. The idea behind quality gates is simple. Catch problems as early as possible. So ideally, before the code is even reviewed by another developer or merged into the main code base. The first layer of this process is a cursor bugbot. Bugbot is an AI-powered code review tool that runs automatically on every pull request. Whenever a developer submits a PR, Bugbot immediately scans the code. It looks for things like potential bugs, logic issues, or risky changes. If it finds something suspicious, it leaves comments directly in the pull request. This means the developers receive feedback almost instantly, often before a human reviewer even starts looking at the code. It helps identify small mistakes early and reduces the time spent during manual code review. It is important to know that Bugbot does not replace human reviewers. Instead, it acts as a first line of defense. By catching obvious issues early, it allows human reviewers to focus on more complex design decisions, architecture concerns, and overall code quality. So the next layer of quality gate is automated testing. As soon as the pull request is opened, our automated tests run automatically. This test verifies that the new code doesn't break anything that was previously working. This includes unit tests, integration tests, and other checks depending on the component. This automated verification is critical because even a small change can sometimes affect other parts of the system. Finally, we have what we call a null gate. Before code can be merged into a main branch, all tests must pass. If any test fails, the merge is blocked. This ensures the problematic code cannot enter the code base. In other words, the system enforces quality automatically. Problems are caught early, fixed quickly, and prevented from reaching production. So overall, this quality gates provide 3 layers of protection. So first, AI-assisted code review through Bugbot. Second, automatic testing that validates functionality. And third, a hard merge gate that blocks problematic code. Next slide, please. From merge to production, how pipelines works. So on this slide, I want to walk through what actually happens after a developer merges code in GitHub and how that code ends up running in production. The key idea here is automation. And once a change is reviewed, approved, and merged, and the rest of the process happens automatically. First, let's talk about trigger. When developer finishes the work, they create a pull request in GitHub. Other developers review the code to make sure it follows our standards and doesn't introduce problems. Once the reviewers approve it and the pull request is merged into the main branch, for example, that merge automatically triggers our pipeline. So no one has to log into the server and no one has to run deployment scripts manually. The system detects the merge and starts the pipeline on its own. What the pipeline actually does, think of the pipeline as an automatic assembly line for software. It performs several steps automatically. First, it validates the code. This checks the project's compiles correctly and that there's no basic issues. Second, it runs automated tests. The tests verify that the new changes didn't break any existing functionality. If any test failed, the pipeline stops immediately and the team is notified. Finally, once everything passes, the pipeline packages the application into a clean deployment bundle. This bundle contains everything needed to run the application in production. So at that point, we have a verified and tested and production-ready package. From there, the pipeline can follow two different deployment paths depending on the system. The first one is the VM path, and this is the traditional deployment model where the application runs on a virtual machine. In this path, the pipeline takes the package application and delivers it directly to the server. It then runs the deployment steps automatically, stopping the old version, installing the new one, and starting the application again. The entire process is very fast. From the moment the code is merged to the moment it's running on the server, usually it takes around 6 minutes. So compared to older manual deployments, they might take hours. This is much faster and more reliable. The second path is the Fargate path, which is what we use for AIMS and newer cloud-based applications. Instead of deploying to a server, the pipeline packages the application as a container image. The container image is then pushed to AWS. From there, the AWS Fargate automatically pulls the new version and runs it. The big advantage of this approach is that we don't manage servers at all. AWS handles the infrastructure, scaling, patching, resource management. This makes deployments more consistent and easier to maintain. So to summarize the whole process, a developer merges code in GitHub. The merge automatically triggers the pipeline. The pipeline then validates the code, runs automatic tests, packages the application, and then deploys to either VM server or AWS Fargate. The point is the whole process is automated. So with that, I'll pass to Jose for next slide.